We are going to talk today about Git, a distributed version control system. My name is Sergey. I'm working as a backend developer. And today we scratched the surface of what distributed version control systems are, in Git in particular. Let's dive into the plan. Here we go. We'll find out why we need to use Git. We'll learn some basic concepts like repositories, commits, pointers, and branches. We'll get some hands-on experience. Someone else came. One moment, please. We'll create a repository, a local one and remote one, make commits, and we'll create branches. Well, some of you might have already heard about Git. Some of you might have been already familiar with this, but be patient. We'll cover all the basics today. First of all, I want to start from this topic, how QA engineers use Git. Why do they use it? Why do they need it? Well, first of all, you can use Git to switch between versions of your application to test them. Imagine that you have an application, web application that has different versions, major 1, 2, or 3, and some legacy without even a number, and you asked to test them. What should you do? Using Git, you can just switch between these versions and test it. With few commands, you can change the application version and do the work you intended to do with this. You can also manage test cases. As much like developers manage their code using Git, you can manage your tests. You can versionate it. You can create new tests, add them to Git. Even if you lost something, it is not lost forever. You can roll back in history and restore a particular file, which is a test case, obviously. Third, you can collaborate with your team members. You can share your test cases. You can share your work with others. And what is more important, you can share only the particular pieces of your work, not everything you have on your local machine. We'll talk about it later in this presentation. No newcomers? Good. So we'll start from basic concepts now. And the first one is repositories. What is it? Repository is just a directory that contains all the files and nested directories with files that you are working on. It's literally your work. And you can create versions of your working directory. Think of it like a video timeline. And every frame of this timeline is version. They illustrated here like version 1, 2, 3. Let's look closer what's going on here. First of all, let's imagine that your directory contains only 2 files, readme and doc.txt. And then you decided to add another directory with info.pdf file. This is your work. You think it is quite complete, and you created a new version, version 2. Now in your Git repository, your local repository, you have 2 different versions, but the directory is the same. It wasn't changed. I will show you what I mean a bit later. And then you decided to remove one of the files. You don't need it. In version 3, you can see the same directory doesn't have doc.txt file, but it doesn't happen automatically. To do that, you have to command Git to create version. We'll discuss all these commands a bit later. Okay, any questions so far? Good. What repositories can be? Well, they can be local and they can be remote. Thus, you can share your work among your team members. Let's look at this picture, and this is quite a good example. Imagine that you are working on this local A machine, a laptop, and your colleague works on local B. Let's say you want to share your work with your colleague. What should you do? You should push your changes from your local repository to the remote repository, which is origin. We'll talk about this word a bit later again. So in fact, you have at least 3 repositories here, the remote one and 2 locals. Each repository has a complete history of the remote repository. You can fetch all the changes from the remote repository to your local repository using git pull command. And you can push only that changes you want to the remote repository with git push command. And now it's time to practice. We'll create a local repository and we'll create a remote repository. Let's go to the console. Oh, sorry. Here we go. First of all, I'm going to create a directory. This simple command creates directory. Let's test it. Let's call it my test. Repo. And cd lets us to navigate to this command, to this directory. And here we go. We now in this directory, it is empty. There are no files. ls just outputs files. As you can see, there is nothing, just empty directory now. And we want to create a file. Let's create something like this. Here we go. We created a README file, which is now in this directory. And now we are about to initialize Git repository. Is everything clear so far? Okay, silence is gold. We are using this command to initialize local repository. After we initialize the repository, we have an output that says us that we are currently on the master branch. We will rename it soon. We'll talk about branch a bit later in this lecture, so it's not important now. And yeah, it says it types the path of our repository, absolute path on our machine. So it gives us few clues. What can we do with this? But yeah, let's keep going with this. After we created the local repository, we are going to create a remote repository. I choose GitHub as a standard to create a new repository. We can do it simply. Going here, GitHub/new. Let's put something. It should be global unique, if I'm not mistaken. My demo. Yeah. We'll make it public. Don't worry about anything below. It is not important now. You can figure out what is it by your own. Here we go. We created our remote repository, so we can work with it. It gives us a clue. What can we do? Well, actually, we already created readme.md file. We initialized local repository. And these things, it is what we will do next. We just need to understand that now there are two repositories exist on our local machine and the one on the remote server. Okay. Now we'll talk about origins. Our local repository on our local machine, it doesn't know anything about the remote repository. We should configure our local repository to know about the remote one. To do that, we are using this command, git remote at origin and the link to the origin. By the way, important thing, we are using HTTPS URL here to demonstrate things, but in real work, I assume you will use this one. I'm not going to explain the difference right now. You can dig deeper into this on your own, but now just make a mental note that SSH URL is preferable. But let's continue with this one. I will explain what it means. This command says our Git that we are going to work with remote. In particular, we want to add origin. The origin is the name of the remote repository. There can be several repositories with different names, but this is the default name. And most likely in your career, you will work only with a single repository, but who knows what can it be. Just keep in mind that this is the default name of the remote repository. And this is the URL of your remote repository that you've just created. Good. Now we configured our Git local repository, and now it knows about the remote repository. We can also rename our, we can also rename our master branch to main, which is preferable, but let's keep it as it is for now. Next we'll talk about files. Oh, by the way, any questions so far? Sure. Okay. Let's go further. Git works with files. There are two global states of your files in the working directory. Remember, the working directory is the directory that contains your work. So there can be only two global states of your files, the tracked and untracked. We won't work with tracked files, right? We care about the tracked files, but we want to do something with them. I will show you what I mean. We'll just, this is just the tip of iceberg, and we'll go a little bit deeper here. The tracked file state is divided into three substates. You can think of it like a substates of this state: unmodified, modified, and staged. So to work with Git, you need to have a clear understanding what each of these state means. We'll demonstrate every case, this error transition from one state to another in a minute. And what can you do with files in Git? You can add them into Git, change them or modify in the Git, and remove them from the Git. Remember, if file was removed from the Git, it doesn't mean it is lost forever. You can roll back your changes. You can go back in history and restore this file. This is the one of the greatest feature of Git, of version controls, of version control system in general. Okay, so let's see what these commands are. We'll go back here to make sure that we understand every arrow of this, and to the console. First of all, let's clear it out and see with git status command what is the current status of our working directory in Git. Here we go. It says that we are on branch master. There are no commits yet. What commit is, we'll talk about about this a bit later. And it says that there is one untracked file. Let's go back here. Here we go. We have only one file in this state, in global untracked state, and we want to make this file staged. What does it mean? Git gives us a clue that we are going to, that if we want to commit something, we need to prepare the files. So we add the file to the staged area. And git status says us that the file is in the staged area. It gives us a clue that we can remove it, but we'll talk about this a bit later again. Now I need you to understand that now we just add untracked file to our staged area. We went from this state to this. This is the direction of the transition that we made. And why do we need this command, git add? This is because we need to say Git what files we'd like to include in our next version, what files we'd like to commit. And this command is exactly about it. It says Git to include this file. Questions? Okay, great. Now, we don't have any versions yet. We just moved the file into the staged area. And now we are going to create first version of our repository. Literally, we commit file. Oops. Before I press enter, I want to explain what is it. This says that Git will create, this means that the Git will create a commit. Commit is a snapshot of your repository. You prepared files for snapshot, now you want to make a snapshot, a version, a frame that I've explained in the beginning on your timeline. And message, it is something that gives you a clue what's going on there, what changes were made. The good practice is to put here something that gives you overall description of what you did. Something short, complex, not very complex actually. Something short and meaningful. Let's commit it. What do we see now? Git says that we created root commit. It means there were no any other commits yet. We created the first one. And there was only one file and one insertion. It means that it created only one file. That's it. And let's go back to our slides. What's going on? First of all, we created a file, untracked file, and added it to staged area. And then from staged area, we committed this file. And now this file is tracked and unmodified. It lives in Git. We can now modify these files. Well, actually, we have only one file. Let's add something into this file. Let me just a random string. And we append this random string readme.md. Let's see what Git status says. Okay, what has just happened? We modified our readme.md, and Git noticed it. Git status says that we are still on the master branch, and this file readme is modified. It gives us a clue what we can do with this. We can add this file. Let's go back here. We can add this file to staged area, or we can restore this file. What restoration means? It means that the Git will restore the initial state of this file before the modification. Let's try this first. This command will bring this file back to the state when it wasn't modified. Here we go. Nothing to commit. Working tree is clean. Think of working tree as alias of working directory. From a manual PA perspective, it is the same. Any questions so far? Feel free to ask anything.
I have one question, sorry. In this case, when we restore a file, I guess the data will be deleted in this file that was modified.
Good question. And yes, well, let's dive deeper into this. We'll use this command, cat. It displays the content of the file. We want to readme md, and this is what this file had before the modification. And this command that we used to modify file, it appends a string at the end, as you remember. See, now we modified it, and Git shows us that the file was modified. And when you restore it, let's find this minor history again. Guess what would be here?
I guess just title.
Yep, correct. That is the title. So it means when we restore file, all the untracked, I need to put it in another way. All the changes we made since the last version will be lost, but the file still exists. It is tracked file. We just roll back the changes we made relatively to the previous version. So is it clear now?
Yeah, thank you.
Great. Let's move on. Again, I added the string to the end of the file, and we see the changes here. It is modified. Now we need to go the other way. By the way, what we did, we had unmodified file readme. We edited it, and now we want to add it to stage area again. And we need to add this to the staged area because we want to create another version of this file. So what we do, we are following this clue, but this time we will use dot. The dot means that we want to add everything that is modified now to the staged area. You should have already known about that by this time. I mean, what dot means, but short explanation is that it adds everything that was modified. In our working tree, we have only one file modified. That's why we just include this one. And see what has happened. By the way, is the font size okay? I can zoom it in if needed. Okay. So git status shows us that the file was added to the staged area. And it was colored with green color, which makes sense. Now we went from this state to this modified, and we moved to the staged area. But what if we are not sure that we want to commit this file in this state? What can we do? We can modify it again, even in this state. We append it with one more string and see. That can be quite confusing. These changes that we added to the commit. Sorry. That was the changes that we added to the commit first, and now we changed it again. And to include additional changes, extra changes, we need to do commit command again. Here we go. Let's display the changes that we are going to make. This is what we are going to commit. Let's commit it. And here we go. Now our repository has history. He has two commits already. Okay, questions? That's good. And let's add another file to demonstrate you what remove the file is. Let's say I want to add something like HTML. Here we are creating a file again, the file named index. It has just this string inside it. It doesn't matter, the content doesn't matter now. And we would want to add it again to the repository. By the way, what if we forgot to type -m this thing? What would happen? Well, our Git will suggest us to use our text editor to create a message, the commit message. So just for convenience, I use it in line using the -m, but here you can type something like index HTML. Wow. Great. What I've just did, you could do this way. You could just add index HTML. HTML file. But because it is already committed, we cannot commit anything else. It will just gives us notification that nothing to commit now. Working tree is clean. Nothing is ready for commit. So now we have two files in our history, in our repository. Let's display them all. README and index.html. And let's say we want to remove index.html because we don't need it anymore. How to do that? Well, there are actually two possible ways. We can remove this file from our file system using rm command, or we can use git in command. Let's use this. And the file name. This is what we did. We removed file, and let's see what Git thinks about it. Well, it says that we deleted this file from the history. From now on, this file won't appear if we committed this message. From the moment, the file wouldn't appear in the following versions of our repository. We did not commit the changes yet. And it says that it would be deleted. And a new untracked file appeared. It is the same file. It is in two states at the same time. It is instaged and it is untracked. Let's commit our changes. Delete. Oops. Here we go. Let's see what is in our working directory now. See, we still have index file here, but we don't have it in the Git history. It is marked as untracked. We have two options here. We can remove this file completely from the Git and from the file system now, but the and we can roll back in history and restore this file. Let's do this. We'll just rm index HTML. There is no index HTML right now in history. I mean, on our local file system, and Git doesn't know about this either. And any questions? Let's stop for a minute. Okay, I take it as everything is clear. Okay. This is what we did. We'll back to this slide a little bit later. Now, actually, let's move into details here. When we remove files from the file system, Git also removes untracks the files. I already showed you the piece where we removed the file from the tracking files in the Git, and then removed it from the file system. We did it with two commands, but in fact, we could do it with one command, with rm command. Let's say if we like this, this would have brought us to this situation where we don't have untracked files, and the index files was removed. I will demonstrate it to you later in this lecture. Another thing that you should keep in mind that sometimes you need to ignore files. Sometimes you need Git doesn't know about anything about the files that you don't want to share with everyone, that you don't want to commit. And this where git ignore comes. If we have time, I will demonstrate you git ignore as well. But you should keep in mind that you are not able to do anything, to do something with ignored files. You can add them, you cannot commit them, and you won't be able to roll them back and restore. And before we travel back in history and restore that index.html file, I should introduce you commits, and let's discuss what is it. Well, remember that original image that illustrated the version 1, version 2, version 3 there, and it is something that was replaced by these versions. I mean, the hash, this thing called hash, it replaced the v1, v2, and v3 signs. We can see commits, in our Git log. As you can see, it says commit and long hash. We won't go into details how this hash was generated. We just need to accept that every version is hidden behind this hash. And it goes up every time. So every time we create a commit, we create this hash. This hash is unique. They cannot be, there shouldn't be collision. There cannot be collision between them. We just accept that they are unique all the time. And hash, it is something that we use to navigate through the history. For example, knowing this hash, we can say git to switch to the particular version of the repository. Okay. By the way, when you type git log, you're entering in the special mode. You cannot do anything here. And to quit from this, you should use Q button. Not Control-C, Control-D, it won't work, just Q. Okay, let's go back here. So now you should understand that conceptually, the Git history contains of two parts. The hash, which is a title of the snapshot, and the working directory state, a snapshot, which usually called a commit. And this is the thing you should distinguish. To switch to a particular state of your working directory, you should know the hash, or at least first 6 digits of that. Git is smart enough to get these first 6 digits and switch to this particular version. Any questions so far? It can be quite confusing, so if you have doubts, just ask me.
No, that's good.
Okay, great. Let's go back. So now we need to understand how the Git history is built. Well, literally, it is the sequence of commits. Every next commit knows what his parents is, or a parent. It depends on what the commit is. Now let's think of it like every commit has one parent. And initial commit, root commit, it won't have anything. It won't just, it will live alone. And every next commit reference to the previous one. Thus, we can navigate from one commit to another. We know the history of the branch. What the branch is, we'll talk a bit later. To navigate through the history, we use usually two commands: the git log, I already showed you what it is, and git checkout. Git checkout lets us switch between these commits. Let's do this. Remember, we wanted to restore index file. So git log. Now we know that we committed index file here, but we are not sure. So to make sure that the hash has a file, we are using git show command. Git show uses hash to display what the changes was. So it says that we added the file and it shows us the file itself. This file contained one string, and we now know that's the file in this commit. And to switch back to that state, we are using checkout command followed by hash. Let's put only first 6 digits here. Not digits, symbols. It can be both digits and letters. P. Here we go. Now Git says us that we switched to this commit, and the state of our repository now is switched to that state, to the state which was hidden by that commit. Git gives us clues what we can do next. We don't care about them just for now. We just want to make sure that the index file is here. So we are just checking it. Here we go. Remember, here the file was missing, and here it exists again. Let's make sure that the file is the same. Yes, the QWERTY string is here in place. Let's take a look at the Git history. What have happened now? And it shows us not 4 commits like it was before, but only 3 commits. And the latest one, it is the commit that we are currently on. So again, what we did. We were here, let's say our latest commit was here. We executed git checkout command with specifying commit hash, and we travel back in time to the particular version, and we restore in the state of the repository at that moment. Any questions?
What if after checkout we change the file somehow another way, like third way, and commit it again? What would it be?
Now, well, the short answer, we will diverge our history. But we can create a branch. So this is a soft approach to branch topic. We'll create a branch. We can create a branch, a standalone history of Git. And later, when we finish our work in this branch, we can merge this branch into the main branch. I will show you what branch is in the next slides. For now, about history, checking out, and git log. Any questions about that things? Okay, great. Branching, the next topic. Let's go back here for now, and I'll show you an easy way to return at the point where you were. checkout hyphen. It's a small trick. It will bring you back to the commit where you was. And now it is master. Here we go, on the master branch. And now we will talk in details what the branch is, why we use it, and what is the benefit of that. Well, why do we need to use branch? Well, if we need to test something specific, a bug fix or a specific version, usually a specific version of the specific branch. It's separate standalone branch, which you can see here. For example, someone asks you to switch to, I don't know, previous version of your application. It means you should switch to that branch and start working on it. Start creating tests for this, testing and whatever you do with this. You can collaborate with developers using branches. For example, there is stable branch called master usually, or main. It means that this branch shouldn't be broken. You cannot experiment it. You cannot not experiment with this branch. You just need to leave it as it is. But you can diverge your history from that branch, make your changes, make sure that your changes work, and then merge it back to the main branch. This is how development is going. This is how you will use Git. Usually, you have several branches. It means that you can share your work with someone else. You can say, hey, I created the branch. Can you take a look at please and finish my work or complete something on this branch? I will show you how to push your branch to the remote repository a bit later. Remember, we have remote repository as well. And after creating your own branch, you can actually break it because it won't affect anyone, because no one else except you or except you and your colleague uses using it. You can do whatever you want on this branch. You can break it. You can roll back in the history. That is the benefits that you gain from using branches. What the branch is? Well, we already know what the commits history is. It's just a sequence of commits bounded together sequentially, one by one. And every next commit knows what's going on, what is the parent of this commit. Back to the root commit. So the branch is like a pointer, a title of this sequence. For example, here on the picture, you can see two pointers, two different branches. They are the same, pointing on the same snapshot. It means that from code or from files perspective, they are the same. They are not different. But here you can see a head pointer. This is another pointer that points to the pointer that points to the commit. Why do we need this? Because when we work with files, with branches, with Git at all, we look through the window. Like, think of head pointer like a window. We are using it to look at the branch or look at the commit. In our previous example, our pointer was moved to here. Let's go back in slides and I'll show you what I mean. Our pointer, head pointer, was here. And after we entered git checkout and the commit hash, our header pointer moved here on the particular commit in the history. And this is how we are switching between branches. We're using head pointer. So, wrapping it all up, we have head pointer, we have branch pointer, and we have commits, which can be which you can think of like let me put it another way. You can think of branch as a sequence of commit. And the branch is just a pointer pointing to this particular sequence. How you can use branches? You can check out on the branch. You can create branches. You can pull branches from the remote server, or you can push your local changes to the remote server. Let's go back to our code, to console, and I will show you. So now we are going to create a branch. Now we are on the master, and we want to work to make some work. We want to make some changes and do it safely. So we won't affect anyone, because master branch can be used by your application that is in production now. You don't want to fail anyone. So you are typing this checkout, which is familiar to us already. And you're using -b to tell Git that you'd like to create another branch. Let's call it my branch. I won't stop on naming of the branches. In fact, it can be anything, but you should follow this style, kebab case, which means hyphens between words, and just press enter. Now Git says us that we are on the my branch, which is different to master branch from the Git perspective. Oh, someone else appeared. Someone joining us. Okay, let's continue. We're stopped. Here we are on my branch, which is new branch to master. We want to make changes here. And let's create another file. File. File txt. Let's call it file a.txt. We're already familiar with process of adding files to the stage. And we already know how to commit them. Here we go. Now let's see what we do. Git log says us that now our pointer head points to my branch, and my branch has this commit. We added a file and we committed it. It also shows us that there is a master branch here, and this master branch is different to this branch. When we check out to the master branch, let me first demonstrate you that now we have two files, readme and file a.txt. And now we won't go back and we want to switch the branch. It doesn't mean we want to go back to history. It is another thing. Git checkout master. Now Git says us that we successfully switched to the master branch. Let's see the file system. File A had disappeared because the master branch doesn't know anything about a file, about this file a.txt. It lies in the my branch. Questions? Okay. And now, to visualize this, we can use our remote repository. We can push our changes to the remote repository and see what would happen. Remember, we have this one. By the way, it suggests us to rename the branch. Let's do this. Let's follow the conventional way of naming branches in Git, at least in GitHub. We'll use this command -m capital to rename the branch we are currently on to main. Here we go. We just renamed the branch. It means that if you mistakenly named your branch, I don't know, QWERTY or any other random words, you can change the name of the branch at any time. And now we want to push our changes to the remote repository. To use it, to push it, we use git push command followed by origin, which is the name of our remote repository. And then we specify the name of the branch we want to push. Main. And here we go. We successfully pushed it. Let's see in our remote repository what just had happened. See, our local file with two appended strings now lives in the remote repository. Thus, we shared our work with others. Anyone can pull these changes using another command. Let's show it. Git pull, which is almost the same as push from the perspective how it looks like. It requires origin, a remote repository name, and branch name. Here we go. It says that there are no changes on the remote repository, and that's why it cannot pull anything. But see, in our remote repository, we have only one branch, which is main. We don't have any other branches because we didn't push my branch to the remote repository. Here's the list of the branches, and there is only one, main. Let's share our work from my branch. We just pushed our next branch to the remote repository. And now, after refreshing the page, we have two branches, default branch main and another one, my branch. Okay. And to show you graphically what we did, -graph will create one moment, please. I don't remember exactly what the option name is. No, let's just skip it because I don't remember the actual name of this option, but
This graph, but you probably have a typo just there. You have
Oh, yeah. Thank you. Thanks a lot. I was sure that I put it in the correct way. Yep, here we go. It says the origin main. This is the straight line showing us that we have only sequential history. And if we switch to another branch, let it be my branch. Typo again, right? Check out my branch. We check out here. We are on my branch right now. Okay. It doesn't illustrate us the diverged history here because from the Git's perspective, they are sequential because the latest commit of main is this one. If it was something else, I mean, if there was two other commits on main branch, the history would look different. Let's try to add the file in the main. I hope I'm not confusing you. I just want to show you the diverged history or how branch look like. Git. Let's create another file in the main. We just need to edit first and we commit it. And here we go. And see what the git log says us on the main branch. Now we need to check out my branch. No, it doesn't work this way. I wanted to show you. Okay. I think I won't be able to show you how graph works, but we know, just take a mental note that if you are on the project with different branches, to make sure that you understand where the point of the diverged history is, you can use this particular thing. Okay, any questions so far about branching, how to create them, how to rename them, and how to push to remote repository? Okay. I remember there was a question, what should we do when we switched back in history to the particular commit and made changes? Let's just return to the situation again. We'll just look. Here we go. We are on this state now. Make sure that there is nothing else. See, no branches around, only our head pointer pointing to the particular commit. And Git suggests us to do several things. You can switch to the new branch. You can do changes here. Let's say we have, let's see what the file is. Yeah, index.html. We want to restore index.html and add something at the end of the index.html file. I'll be qrt to string. Here we go. We moved our history further a little bit, and now we can switch to the new branch. Branch name. If I remember correctly, we should do this before we make changes here. No, yep, everything is all right. So now we have 3 branches: new branch, main branch, and my checkouts. My branch. Yep. To view the history of the new branch, we should have typed this git log on that branch, or we can use the git log help to output the history of the particular branch with more options. Okay, let's return to our branches. So I demonstrated you everything related to repositories, to branches, and to commits. Any questions about these things? Any questions about the entire lecture? Okay. So I guess that's it. That was just basic of the Git. We just scratched the surface. There are many more things you can do with Git. You can read the textbook for more details. You also will find links to Gitbook. This is the textbook from Git itself that explains everything in details, how to work with Git's most common techniques and Git flows. And you can use special tools that will be provided by Mentorpiece to practice your skill with Git. I will ask again, any questions about the lecture, about anything?
Not right now, I guess.
Okay. So if there is no questions, I want to thank you for your attention, for your questions, and I hope we will see you again on the other lectures. Thank you, guys.
Thank you.
Thank you.
you.
Thank you very much.